All right, guys, welcome to the first part of Unit 4. We're going to be covering Chapter 7, Linux and Macintosh file systems. But right before I dive into this, let me address the midterm. So a lot of you are wondering, what's on the midterm? There will be a post about this, and I'm sure you'll probably watch this hopefully before you take the midterm. And it's going to cover everything. Pardon me, I have a little itch. It's going to cover everything we have covered so far. So review the slides, and the midterm is open note, open computer. In the real world, if you're doing a task, you think there won't be a computer in front of you, I guarantee you there will be. So that's what it's there for. Answer them, or either answer the questions to the best of your abilities. And please don't copy and paste answers. I want to know what you're thinking. So please write everything in your own words. That's all I ask. And it will be available Sunday, and I'll probably make it available for let's see. Everything will be due Sunday lab-wise, and I'm thinking 4 labs for this week. One will be a lab from the previous chapter. There's a reason I didn't include it yet because it kind of pertains a little bit to what we're doing in some of these chapters, hence why it wasn't added. Will be one of those, and then we'll have three more labs from here. So it'll probably be 1 lab from each section, and that'll be it for this week for labs because I know you have the midterm. It's gonna be a lot more to do. So that's about it. That's all I have for you in terms of assignments this week and the midterm. Oh, and it'll be available Sunday, and I'll probably have it run all the way until the Wednesday after this coming week. So you guys will have a week and so about 10 days to do it. That should be more than fair. Please get it done. If you don't get it done, turn in late, I'll let it slide for now, but I will not make it available beyond probably Friday of even the week after it's due. So get it done because the final will be coming in about 2 weeks and it will cover everything. It'll be a full comprehensive final. So let's get into this. Enough talking about midterms, finals, and everything else. I mean, you guys are in week 4, by the way. You're past the hump. You're past the halfway point. So let's dive into Linux and Macintosh. What's the Microsoft file systems here? So, and my keyboard doesn't want to function. That's just lovely. So here's what we're going to cover for objectives. Describe Linux file structure, describe Macintosh file structures, use Linux forensic tools. There will probably be a lab with Linux. You're probably going to need a virtual machine. I'll set one up. If you need help setting one up, please, again, inbox me, email me, or, try to find me somewhere on Discord if you join the Discord. If not, it's fine. I keep mentioning it just so you guys know it's there. That's all. It's not, you got to join. I get it. So, Unix. Let's examine these file structures in Unix here. Or Linux, but Unix. So here's a couple of Unix distributions. Silicon Graphics Incorporated, SGI, IRIX, Santa Cruz Operations, Unix Wire, Sun Solaris, IBM AIX, and HP Unix. Linux distributions. Ubuntu, which I've used a lot, CentOS, I haven't really used. Mint, I haven't touched. Fedora, I haven't touched, but this is kind of an older slide. Fedora is still kind of used, but now you have to pay for it. So a lot of people are moving away from Fedora in industry and moving more towards Kali Linux or Mint. Gentoo also is popular. It's alternative to Fedora now. Linux is only the core of the OS. That's true. They're all built. Ubuntu, CentOS, Mint, Fedora, and Gentoo are all built on Linux. Also, Unix-like OSs have a kernel, so do all Windows OSs. Yeah, kernel is just common for all of them. Tell you what, for extra credit, show me what the definition of a kernel is. 5 points. Have fun with that. Okay, so remember that Unix and Linux commands are case sensitive. Yeah, if you type in something wrong, so let me bring up something up here. Give me a second. Let me just do go to images, and it'll be in here. Don't worry, I'll drag it over. Let me think off the top of my head. Linux commands and yeah, that's good. That'll work. Let me go to visit. Sorry, guys. It's a website that I kind of want to show you, but I want the image. Hold on. Speaking of like, open a new tab. That's all I want. All right, enough piddling around. Let me just drag it over. Yeesh, that is tiny. There we go. This will work. So these are all the kinds of commands you can have in Linux. It's not the greatest thing on the planet, I know. But ls is directory listing, ls-all, format listed within files. These are all the kinds you can do. So don't go too crazy looking at all this. Just I'm showing you what they are. That's why they're here. You will do a couple of these in labs. I'm sure I will make up a lab if I have to for it. It's not bad. But the thing is, if you type in ls and you type in, I don't know, KS by accident, it's not going to know what you want. You got to be very, very specific in what you're doing. That's what it's talking about case sensitive. So the Linux commands are on page 310, 312 if you want to check them out. So, Go bananas and check them out if you like. That's fine. Let's move on. This is 43 slides, by the way. I will try to get this done in one take. So this lecture shouldn't be more than maybe 40 minutes, hopefully. We'll see how it goes. So anyways, so moving on to the file structures in ext4. The early file system standard was second extended file system, or ext2. Third extended file system, ext3, replaced ext2 in most Linux distributions. I can't give you a definitive hard date when it happened, but it was probably after the launch of Linux, somewhere around 91-ish, whatever Wozniak decided to launch it. And then fourth extended file system, ext4, added support for partitions larger than 16 terabytes, improved management of large files, and offered more flexibility. Adoption of ext4 was slower in some Linux distributions, now considered the standard file system for most distributions. Give me 1 second, guys. Never mind. I thought somebody was trying to come in here to my garage where I record everything, but we're good. So ext4 is now the standard for Linux. Just it's been the standard for quite some time. I can't really tell you the date because I'm not too sure of it myself, to be honest. Linux is kind of a hodgepodge at times of when things are released. Sometimes they're released early and work, then they pull them back, and you kind of go back and forth with it. So keep in mind, Linux is also free. So if you haven't played with it, that's okay. We will play with it. Moving on. Everything is a file. Files and objects with properties and methods. So yes, everything in Linux is considered a file. Unix/Linux file systems consist of 4 components: of boot block, kind of like a boot sector. Contains a bootstrap code. Linux, I just say Linux, it's the same thing technically. Only it has a graphic user interface at the time, Unix does not. Computer has only one boot block located on the main hard disk, so we know it's there. Superblock specifies disk geometry, available space, and keeps track of all inodes. That is a very weird phrase. It manages the file system. Inode blocks first data after the superblock assigned to every file allocation unit. Data blocks, where directories and files are stored on a disk drive. That kind of makes sense so far, right? This location is linked directly to inodes, so they kind of cascade. So this goes to here, and that goes in technically behind him. So they're kind of in order already in this slide, which is kind of nice. So that's cool. Moving on, we're talking about inodes. God, I do not like that word. Contains files and directory metadata. So remember what we said what metadata was on a file? So if I bring up, you go to my desktop here, and just to refresh your guys' memory, this is something from CTIS 12 that I did a while ago. It's just the overviews. This is metadata, right? All this here is metadata. So that's what it's talking about. Go back. Contains also linked data storage and data blocks. Cool. As an assigned inode contains the following. That might be a midterm question. Hint, hint, such, wink, wink. Where is my? Give me 1 second, guys. I need to find something down here. Something I use to take notes, and it's kind of pulled a Harry Houdini and disappeared. Be right back. All right, guys. Found my scratch pad so I can write stuff down. So where was I? An assigned code contains the following: mode and type of file or directory. Cool. Number of links to a file or directory. UID and GID, which is graphic ID, the file or directory owner. Number of bytes in the file or directory. Files or directories last access time and last access time and last modified time. All right. An assigned inode contains the following: inode's last file status change time, block address for the file data, indirect, double indirect, and triple indirect block addressing for the file data, current usage status of the inode. That's a lot of info it carries there, huh? Number of actual blocks assigned to the file, so how much hard drive space in terms of blocks and shoot, what was it called? Sectors. File generator number, version number, continuation inode links. That's a lot of stuff. First inode has 13 pointers. Pointers 1 to 10 are direct pointers to data storage blocks. Pointer 11 is an indirect pointer. Links to 128 pointer inodes, and each pointer links to 128 blocks. So that's kind of a 1-for-1 there. Pointer 12 is a double indent pointer, indirect, sorry. Pointer 13 is a triple indirect pointer. Here's what they look like. So blocks 1 through 10 are here. They point from 1 through 10, but block 11 is a special guy. It goes to 128 pointers. That points out here. 11 to 138. Then block 12 is a double, remember? Goes to here. Points to 139 to 128 to the square 2, power 2. And this is a triple pointer, points to a bunch of 28 pointers, and so point to this guy down here. It involves a lot of math, don't worry, we won't get into it. Moving on, innodes number 5. Bad block inode keeps track of disk bad sectors. So it's kind of similar to Windows, where it keeps track of the bad sectors too. So, or sorry, Microsoft's version of FAT32 and NTSF. Excuse me. To find bad blocks on a Linux computer, use the following commands. Bad blocks must log in as a root user. What slide is that? 12. I'm gonna try that myself. That's what I'm writing it down. That's not too hard. That could be a lab. I'll think about it. Make 2FS and E2FS check include safeguards that prevent them from overwriting important information. So that's what we got for innodes. Let's move on. Hard links and symbolic links, 1 of 6. So 6 slides of this stuff. What's a hard link? A hard link's a pointer that allows accessing the same file for different file names. Okay, use the ln command to create a hard link. Yeah, it's pretty simple. Here's what that looks like. So these are all hard link files with different file names. So it's called tracking database. DB means database. My data file. See, they're all different users too. USR is user. So user Rory has tracking database in there, and under user, I'm assuming that's why it's in there. And my data file, then Diane, has company database. So it's all linked into the user file. Sorry, guys. Been rough for a Monday. It's a spicy Monday today. Minus no fires this time. Link count. I filled inside each inode that specifies the number of hard disk links. Hard links, I'm sorry. So here's what that looks like. That's what Ubuntu looks like, by the way. So dot indicating directory, dot indicating current directory. So this means where you're at. That means the parent one above it. This is what that looks like. You'll see it later. Don't worry. I'm sure I'll make a lot about some stuff like this. It's not hard. It's pretty simple. Might do some forensic stuff in Linux. I don't know yet. I don't know how comfortable you guys are feeling it, but we'll figure something out. So symbolic links. Pointers to other files are included in the link count, also known as soft links or sim links. 1 second. Can point to items on other drives or other parts of the network. Have an inode of their own, not the same as the inode of the item they are pointing to. Depend on the existence of the destination they are pointing to. So inodes can kind of vary, or the links rather can kind of vary. So here's what this looks like. Creating a symbolic link. They use what did they use? ls-l, mysim. TMP, that's test symbolic link. Then it points to the new folder temporary is TMP Linux. And did a lot of change. CD, I'm sorry, I'm gonna get a little bit into it. CD up here means change directory /temp. So they went change. It's kind of like when you go to Windows and go to let me see if I can do it so. Yeah, it does work. It's kind of the similar when you do this on Windows. Watch, let me show you. Only in I'm in command prompt. It's similar to Linux, it's not Linux. So if I do CD change /C, now I'm pointing in C drive. That's kind of what CD /temp is. Well, that's /. I'm sorry, I'm back. It means forward to temp, make directory temp system. So they created the folder for creating it in there. And they changed again to point to it. Then they're in there. Then they did touch test 1, test 2. Change directory .. to the file itself, which points to temp again. So they went back essentially with it. And they did all those other commands. Don't worry, I'm not going to do that in Windows. It'll take too long. So let's go on to slide 19. Mac OS X version 10.13, codenamed High Sierra. Current version. Yeah, no, that's not the current version anymore. What is the current version? I'm curious. Not big. It's Mac OS is essentially Linux with a pretty screen. So what's the current version? We'll find out. There we go. Latest version. We're on Mojave. Oh, my bad. Monterey. Sorry, I was thinking of version 10. So the latest version I have found is Monterey. Big Sur still supported too. Good to know. So, no, this is kind of not relevant anymore in a sense, but it kind of still is. Offers better security encryption, yeah, I guess. With OS X, Macintosh moved to Intel processors and became Unix based. Well, they were Unix based even prior, technically, on their Apple PowerBooks. But Intel, they got rid of Intel recently. Remember, they bought ARM. Maybe you heard of it. Now they're using their M1 chip, which is pretty decent, but just because Intel's been going through some struggles lately, but I'm not going to get into that right now. So moving on. Before OS X, hierarchical file system, HFS, file stored in nested directory folders. That's true. That's how they used to operate. This talking about Mac systems. Sorry, guys. Extended file format system HFS Plus introduced in Mac OS 8.1 supports smaller file sizes on larger volumes, resulting in more efficient disk use. Then the Apple file system, that's where that came out. Introduced in Mac OS High Sierra. When data is written to a device, metadata is also copied to help with crash protection. Yeah. So overview of Mac file structures, we're up 7. We're going to be here for about 7 slides. We're already on slide 21, guys, and we're about 20 minutes in. So not too bad. If I'm kind of flying through stuff, it's because I'm not going to have you guys replicate a Mac, to be honest with you, unless you have a spare one. Be my guest. I don't expect you to buy this device or play with it. I don't even think I can grab an image of it, honestly, and give it to you. We can make a virtual machine. It sounds like it'd be a hassle because it requires sometimes some chips or something. If you hear some bells in the background, it's been chime. Give me a second, guys. All right, guys. Sorry about that interruption. Someone came into the garage to grab something. So back at it. Garage/office, you know. In a Mac, a file consists of 2 parts, data fork and resource fork. Stores file metadata and application information. So that's what they both do. Data fork typically contains data that the user creates. Kind of makes sense, right? It's just text or spreadsheet. So data contains things you create. Okay. Applications also read and write to data fork. Okay, so segue that way. Resource block contains additional information such as menus and dialog boxes. So, tabs, everything you see on top. A volume is any storage medium used to store files. It can be all or part of the storage medium for hard disk drives. Some difference. Here's what that looks like. So here's the data and the data fork. And it's a simple Mac file. Here's a resource map. All the stuff it's using. Resource fork and data fork are those. Yeah, it's just an example of what it looks like. That's not too crazy. Essentially, it's kind of like, I would say it's kind of like a layered approach, a one-to-one approach. So one file, but one, 2 items each, 1 item each to one thing. That makes sense. One thing's data, one thing's resources, like that. Get the file here. And volumes have allocation and logical blocks. Logical blocks cannot exceed 512 bytes. Allocation blocks are set of conclusive logical blocks. 2 end of file EOF descriptors are logical EOF, actually end of the file name, physical EOF, the number of the bytes allocated on the volume for a file. That's interesting for physical, because physical is something usually we can touch. So it's associating the number of bytes allotted for the volume for a file, which kind of makes sense because it's physically on the drive, but it's not something you can physically touch unless you reach in there and take the hard drive out, but you wouldn't know where to touch. You get what I'm saying? But essentially it is physical. It technically isn't, if that makes even some sense at all. Sorry, Mac file system's a little weird at times. So here's what that looks like. So allocated block, files allocated, and the Mac volume. So file A is logic block 0 to 2, allocated block 0. That's kind of that chunk becomes block 0. I guess it's being named after the top block. Or not? No, it's something weird. File B is logic block 4 to 5, allocated block 1. Yeah, block structure is really weird, man. Really weird to me. File C is logic block 7 through 10. It's allocated block 2. Then block 11 to whatever's next is allocated as a block of data. Here's what that looks like again. A little bit different. Allocated block 1. File B allocated in block 1. Logic block 4 to logic block 5. Runs from byte 0 to 511 bytes. Logical end of file. Ending byte position has file B. So here's where it ends. Then byte 512. Physical, so this part's that's written here. And it's byte 1023, which is roughly double these 2 bytes. Yeah, that's about right. So it's the whole file it's looking at. So that's all physically there on the drive. So moving on, clumps. Groups of continuous allocation blocks reduce file fragmentation. So it kind of groups things into little sectors, or not sectors, little clumps of data, I guess you could say. Older Mac OSs use first 2 logic blocks 0 and 1 as boot blocks. So if we go back, we know that 0 and 1 are used. So these 2 will be for booting, and then everything else will be for files and whatever else. So that makes sense. So the OS would kind of section this out based on what they just said there, which makes sense. So it did work. Master directory block, oh, that sounds familiar. Or volume information block, VIB, which is all information about a volume. Volume control block, VCB, stores information for MDB, which is master data block when OS mounts. Yeah. Extensive overflow file stores any file information not in the master directory block or the volume information block. Makes sense? Macs are weird, guys. That's all I would say. Catalog, the list of all files and directories on the volume. Maintains the relationship between files and directories. B asterisk tree. File system and earlier Mac versions. It's not really that common anymore. Actual file data is stored on the leaf node. B asterisk tree also uses header, index, and map nodes. That's don't worry, I won't get too much into it for Mac stuff. I don't have a Mac in front of me either yet. So personally, I'm not a Mac user. And if you are, good. I mean, to each their own, right? All right. There are some differences between Linux and OS Mac file systems. Linux has home, username, and root directories. This is yeah, whoops. I didn't want that to happen. Yep. And the Mac OS the folders are username, and private var root. So what winds up happening is the root becomes essentially kind of locked in Mac just for security reasons. Air quotes on security, because now even they get affected, but it's not the point. The backslash home directory is the Mac OS, but it's empty. Mac OS users have limited access to other user accounts, files, and guest accounts is disabled. In Linux, you can turn that. Linux is like having, oh God, I kind of don't want to say Legos because Windows is more like Legos, but you can literally, it's like building a model airplane, It's the best way I can describe it. You can put anything anywhere where you want in Linux, technically, if that makes sense. You can make the landing gear retract, come out, do whatever, pushing this button. That's what you can do with Linux. Where Mac is like, you can kind of do that, but you can't because if you push this button, it only does this. Limited to what you can and can't do. It's really customized. That's what it winds up becoming. So let's talk about forensics in Macs a little bit here. Did I skip one? No, let's just tell you where the roots are. Don't worry about it. I guess I technically skipped the page, but it's still forensics, right? For forensic procedures in Mac OS, you must know where the file system components are located and how both files and file components are stored. Application settings are in 3 formats: plain text, plist files, and the SQLite database. Plist files are preference files for all applications on your system. So that's kind of like DLL files for Windows, I would argue, and .ini files in Windows as well. Those because they're plist in a Mac. Excuse me. File vault is used to encrypt and decrypt users' users directory. That's the layer of security that Macs have. Keychains. This you'll see still to this day. Keychains I've seen for quite some time in Mac. Keychains, this is how they work. Files used to manage passwords for applications, websites, and other system files. The Mac application keychain access enables you to restore passwords. So it's kind of like a Rolodex, I'd argue, for your passwords. Deleted files are in the trashes folder. If a file is deleted in the command line, however, it does not show up in the trash. Oh, that's good to know for a Mac. I never knew that. More you know, right, guys? Acquisition methods in Mac OS. Make an image of the drive. Remove the drive from a Mac mini case is difficult. Yeah, they're not that exactly repair friendly. Let me show you. This is where getting your hands dirty kind of makes sense. And I mean dirty in terms of taking things apart. Mac mini so I wonder what's talking about trash can bag. The reason I say trash can, there was one that was spherical. That's what I was thinking about. I don't mean that as an insult. Trust me. Let me see. Slow unit body. I'm pulling up something from this. From iFixit. Let me make this bigger. Since you can see the screen. Let's go with the newest. See how hard it is to take apart. Tear it down. What does this have to do with us? Well, it's just something you might have to consider. This is what I'm talking about. See how hard it is. Step 1. Does that come off? Yeah, okay. That twists off. Now to get in there. Good. Torque. Sorry, I can get into hardware and stuff all day. So you don't plug something there. It's not the greatest, guys. Let me see if I can make this bigger. I mean, that's what that looks like without the plate. So you're getting somewhere. But then there's this to remove that's just to remove the fan. Jesus. I bet you that's an exhaust fan too. The processor thing's right there. There's power connector. Sorry, I'm gonna get into this real quick, guys. My curiosity's peaked. So you gotta unconnect it there, then you remove the power. Is that power? Yep, power supply right there. That will be power. That's what that looks like. I'm just curious to see how hard it is to tear this down because you're already on step 8. And you got the Torx drawer. Torx, which is these guys. Torx are kind of screwed, if you're curious. Jeez Louise. All this work just for taking this apart. Is that how you get the ring out? Well, that's how you get power supply out. Jeez. That's the power part. So that comes out. So the board came out. That's out. And this is what makes up a Mac Mini. It's crazy. It's a small board. It might be one of their laptop boards, or even iPad boards they repurposed. They've been known to do that. That's a speaker. Yeah, it's all of my two T6 screws. You're assuming say T6, T10, or Torx. There's a different kind of screw, so you unplug the wireless card, I'm assuming. Or Bluetooth antenna. My bad. That's what those two represent. That comes off. Power button connector, that comes off. Jeez. I mean, it's 15 steps so far. It's 16 steps. Like, you can take it apart. That's fine, but there's a chip. Yeah, that's kind of a pain. Anyways, sorry guys, I gotta show off, but it was my curiosity getting better. Let's move back onto this. Let me go back to my slide controls. Anyways, make an image of that. Good luck, because it's baked on. It's gonna be a little harder than what it used to be. Remove the drive from the Mac Mini. Yeah, there's no drive now. It's baked on. So there's probably newer tools out there. I will look into that for you if you're curious. Let me know. Then to do so with Apple factory training code damage the computer. Yeah, you kind of gotta get specialized for these things because Mac is kind of a pain. Also difficult for Mac Airbook. You need special screwdrivers. You need Torx. You need specific kind of Torx drivers. Oh, you know what? Because I keep saying Torx, let me show it. So you'll be like, what the hell are you talking about, Al? This Torx. Just set. I mean, it's not the best picture, but you'll get my idea. When I move this over. That's what they look like. I know it's not the best. I want something like you guys can see. That's an OB. Well, it's fine. I'll go there. So they have different kind. Let's do that. They have different kinds of bits on the end. See, that's a 10. That's an 8. That's a 6. That's a 5. That's a 4 or a 3. I forget. But not using this as an advertisement for any of this. It's just yeah. See, that's essentially what they're kind of used for. But that's what they look like. That's Torque set. Anyways, hopefully that satisfies your curiosity. Get a set if you can. If you're working on stuff, you never know. Anyways, use an Mac OS style forensic boot CD and DVD to make an image. The thing about Mac is if you can intercept it before it boots, that's the hardest part of these things because they have a security chip that won't let you override most of the time. So there's specific forensic software, which I have to figure out which ones they are, that can be used with the Mac. But again, if you're curious about it, let me know. I can totally give you guys that info. So let's continue these acquisition methods. Blackbag Technology sells acquisition projects designed for OS 9 and OS X. So there you go. It'll be under Blackbag, I'm sure. Let me pull it up because this is somewhat older slides now. Let me see what we have here. Blackbag Technologies. What do they got? Well, they bought something else, but let's see what they have. That's the Windows ones. Let's bring it over. Let's explore for a minute. Yes, I know I'm dragging this out. But let's see. Mac acquisition. It's like the Inquisition for Macs. No, I'm kidding. So this is out there. That's pretty cool. I didn't know this existed. Yeah, this is it right here. It's just for phones. That neat. But you gotta buy it. Unfortunately, it's really custom. Do you have anything else? I want to see products. Sorry, guys. I'm being curious. Resources. Yeah, they don't let you do much. That sucks. Maybe I'll reach out to them, and next time we offer this course, we can do something with the Mac. We don't like melt the Mac. I'm kidding about melting. I'm referring to that in the sense of you can damage stuff because you never know. Especially with this kind of stuff, I don't want to break anything. The heck, is that all they got? Products? Let me see Blacklight. I'll get back into it, guys. I'm just kind of curious. Yeah, that's all there is. I'd have to contact them for more information. That sucks. Anywho, so these are the tools that exist I know of. Nice to know. Anyways, Mac question is a forensic tool. Yeah, that's the only way we just talked about. The forensic boot CD that makes an image of a Mac drive. So that's what you would use if you have it. After making acquisition, examine the image of the file system. The tool you use depends on the image file format. We established that, they either use their own image or they use a, what was it? DDW file type that can be read by most. I forget the name off the top of my head. So, more tools. Tools for working with RAW. Sorry, RAW is what I was thinking about. Format image. Blackbag Technology, Macintosh forensic software, which we just talked about. So, Soft, Mac Forensics Lab. Let me see if that one's cool. Is this? This is kind of old. Oops. I'll use this one now. Yes, I'm doing this and it seems like I'm all over the place, but curiosity. That's the better of me sometimes. Ooh, yeah, it's there. Let me see. Yeah, I don't trust this. This doesn't look. What's from Macworld? That's ancient now. Mac and Farmer, I guess. Macworld was something back in the day that existed. There's some test results from DOJ. That's pretty neat. From like 10 years ago when these slides were probably made. No, these slides are. Oh man, these slides are 4 years ago. Yeah, I wouldn't trust this. This looks kind of old. So what else is there? Guidance in case that should still be around. That seems a little more prevalent. You know what I mean? Guidance software in case. Yep, that's still there. Products. That's all cloud stuff. I'm not showing it to you because it's just a big sales pitch. That's what I'm looking about it. Recon's around. That one's still big. I remember Recon from back in the day. Well, back in the day was a couple years ago. Yeah, it's a real software company. Whatever sends me there. There you go. Yeah. So you can use that with Macs. That's cool. Good to know there's more tools. It's always nice to know. Mac's a little finicky, but I mean they're popular. They got like what, 14% of the market now? X-Ways Forensics, and then Access Data FTK does work. So that's kind of nice to know. But remember, it has to be raw. Right, raw formatted or it won't work. So let me look at X-Ways and stop looking up. I'm sorry. Yeah, that's still around too. Oh man, this stuff is old. I still run an XP. That's dating myself here. Does this support Windows 11? Yeah, but where's the Mac version? Oh, I mean, it does a lot here. If you're curious, let me make this bigger. There is everything it supports. Training, all the stuff you can do for it. But here's everything you can do. Look at that. Hash calculators. These are a bunch of different hash types. Remember, you can be SHA-256 before. Ripe MD. Wow, I haven't heard that in a while. Tiger Tree. Tiger's somewhat recent-ish. Heavenly-ish. It's not super recent. Like software array. This is powerful stuff. Don't worry, I won't have you mess with it. This is a little too far down the deep end, if you know what I mean. We don't want to get into this stuff too far. But here's what that looks like. So it looks like it's pretty simple to run. Yes, maybe we'll do something. No, I'll think about it. I will consider this. I'll add this to my maybe list. Maybe add a bookmark to it. Yeah, I'll put it in my class folder that I have. I have bookmarks for a bunch of stuff, guys. So that's just stuff I might look into the future. Anyways, sorry, back to this. First two tools can disable and enable disk arbitration. So I believe that would be the write function, read-write function, in the sense of locking it. Being able to turn off the mount function in macOS allows you to connect to a suspect's drive to a Mac without writing. Yep, great blocking device. That's exactly what you want. So it would be these two. But the sub, whoops, damn it, I hate when I do that. Sorry, guys. Go back. The Sub Rosa one, I don't know. I don't know how much to trust it. It didn't look legit anymore because it was being hosted on CNET of all places. Like, why would they have it? If this is a big paid software program. So moving on. Linux forensic tools. Aha. Those commercial forensic tools can analyze Linux, ext2, ext3, ext4 formats, Riser FS, or Riser 4 file systems. Reset. German, so it would be reset. Freeware tools include SleuthKit. It's a web browser interface, autopsy forensic browser. Foremost, a freeware carving tool that can read many image file formats. Configuration file formats.config. Fireball, these are the types you can use. Oh, by the way, which I should have mentioned, but it should be kind of noticeable. Fireball, a data file containing one or more files or whole directories and their contents. Download the most current version in SleuthKit. Hey, let's check it out. Let me see what's in there. I'll pull it up. I'm sure my ISP is going like, what the hell is this guy doing? I see there's SleuthKit. SleuthKit, this guy. It's out. SleuthKit. Download. Oh, this is going to be very, very text-based. I don't know if I want to go into this that far. Well, that's what you can do with it. But, yeah, let's go. Move on. So when you run it, yeah, starting autopsy in Linux. That's what that would look like. See, it's very graphic based. So you tell autopsy, then D, and that's where you want to make your evidence locker, which is D, I believe, is directory. Off the top of my head, or is that dir? That's dir. What is \D? Sorry, let me find out for you guys. So it's going to bother me because I don't remember. I haven't used Linux like in a year, so year or two. I can help. Gosh, is it, dude? It's been a while, guys. I'm sorry. Anyways, that's what it looks like when you run it. It's somewhat important. We'll probably do something like I said about it. I'll figure something out. That's what's running Sleuth Kit. So that's what the old website used to look. Let's see. It's web based. So you would open a case, new case, all that jazz. It functions the same practically. 714. I wonder which the figure that is. Is this all we have? No, there's more. That's what it looks like when you make a case. Remember, I said it's web based. So you punch in, you know most of the stuff. So you know what it looks like from playing it within on Windows. So I don't know. I'm thinking about making a Linux lab. Maybe not, because you guys might get a little too confused by it, and that's not what I want. I'm sure I'm pretty confusing as it is as an instructor, so I apologize for that. Anywho, so let's do a summary of this chapter, and then we're done here. Unix was created to be a multi-user, multi-threaded, secure operating system. The Linux kernel is usually packaged with other software components such as graphic user interface and applications. Yeah, if you load Ubuntu, it's pretty easy to navigate-ish. Linux supports a wide range of file systems. Unix and Linux have 4 components defining the file system: boot block, super block, inode block, and data block. In Linux file system, a hard drive is a pointer that allows accessing the same file by different file names. Before macOS, the file system HFS and HFS Plus were used. Older versions of macOS, the file consists of 2 parts: a data fork and a resource fork. A volume is any storage medium used to store files. Plist files are preference files for install applications on macOS systems. And macOS unified logging has been added for recording log files and includes new utilities to help forensic examiners. The biggest challenge in acquiring images from macOS systems is often physical access to the drive. Yeah, because Macs are a pain to take apart, and now that they're getting everything baked on, it makes it a little harder. Linux forensic tools are often freeware. Yep, they develop for free. So that's all there is for this one, guys. Catch you in the next one.